Okay, hello. Hi everyone, and thank you Eric for the kind introduction. My name is Albert Tissot. I'm from PAL Robotics. I'm here with Olivier Stas, researcher from LAAS-CNRS, head of the robotics department, as well as with my colleague Maximilien, who will be operating today the Kangaroo robot. Yeah, we'll showcase, besides the Kangaroo that you'll see on stage, our humanoid robot. We'll show how the collaboration between labs, product labs and research with private companies helps make better products for research and industry. So yeah, I'll leave the floor to Olivier to proceed.
So thank you. So to give a bit of context, we have been working with PAL and PAL France for 10 years. Actually, PAL France was created to work with us. And as you can see, in 2016, we have been specifying one of the first humanoid robots targeted for industrial application. What does that mean compared to the smaller humanoid robot that you have seen that we are aiming for example, going to factories, handling drillers, which are heavyweight, with the arm stretch, okay? Yes, and this means that you need really powerful arms to do such kind of things and powerful legs in order to handle this. Now, as you may have seen all these super nice small robots which are super fancy. The problems, as if you follow a bit the trend of agility robotics, one of the first humanoid robots which has been tested on logistics, there is a huge technological gap to go toward humanoid-sized robot. And this is the reason that we have this crane over there to protect the robots. And for this, we have been working in a first European project called Memory of Motion, where we extended some of the techniques that were used by Boston Dynamics for the Atlas hydraulic robot, making the backflips. Actually, when they were doing scientific presentation, they were citing 5 papers. 2 of them were coming from our team. And we started to do torque control robot, and this is one of the first commercial torque control available robot, which is make it natural to interact physically with the robot. We are focusing for us on the physical part. Then we got Star of Europe for this project. We started a new project which is Agimus, targeted, for example, for mobile manipulator. There is one on the stand of PAL France that you can handle it on the same kind of technology, cheaper, and with which now we can do deburring, something that, again, factories want to do, removing this small metal leg part after making drilling. And we're able to do this, handling planning, real-time control, torque control. You can interact with the system, and we're able to go inside some of the complex pieces of Airbus in order to do this kind of deburring. And at the same time, we created, thanks to the RENOIR, a LabCom with the PAL France to actually develop these new robots that I'm going to talk later on. And we gave a lot of feedback, but it's taking a lot of time, a lot of iteration in order to achieve this kind of results. And I'll let Albert continue.
Okay, so we'll get a bit more in depth in the products we have in PAL Robotics and how the collaboration really helped us push the product forward. So what you see here on the slide is our TIAGo Pro robot. TIAGo is an acronym. It stands for Take It and Go, which is the type of use case it was developed for, which is a use case we find a lot in industry, now to manipulate one object, taking from point A to point B. It's a lot of manual work that is actually in industries that we aim to address with this robot. So some specificities of this robot. It has 2 arms with 7 degrees of freedom each, with joints that are controllable in torque. As Olivier explained before, we've worked a lot on torque control with LAAS. Mainly with the Agimus project, with which we have actually implemented this type of control on this robot, which makes the control of this type of robot compliant and then inherently more safe. The arms are also equipped with automatic brakes that trigger in case of unwanted emergency stops, which then the behavior that the robot will showcase when it stops, that the arms will freeze in place, compared to other robots where the arms might fall, as it might be the case maybe with some humanoid robots. So in this case, the robot freezes in place without harming humans around, the environment, equipment, or even the robot itself. Quick word about the base. It's equipped with 2 lidars, which make it aware also of humans in its vicinity, with cameras, which allow it to deploy SLAM navigation algorithms for robust navigation. So all these technologies, let's say, are different layers also of safety, which make this robot certifiable in safety in certain specific applications. Moving on to the software stack of this robot. This robot, as all PAL robots, are integrated in ROS2. We are a company that's really committed to open source, to really help push the research forward. So yeah, we maintain the repositories, and to use one of these robots, you'll have all the functionalities right off the bat for you to develop your own applications or conduct your own research if you use one of our robots. Quick word also on the human-robot interaction capabilities of this robot. PAL really has also had a strong commitment to social robotics since the beginning. So this robot, as all PAL robots, besides being focused on applications, research, it's also focused on the capabilities to interact with humans. Because also we strongly believe that the way robotics has to be rolled out, the human has to be put in the center, so then the robots need interaction capabilities with the humans. We also have developed the cross-HRI modules in PAL Robotics that can be equipped on this robot to interact with humans. Just to finish on this robot, it can be used to develop research on any types of research, but also on industry applications, as we were saying earlier. Okay. Moving on to the...
Thank you. We will now have a demonstration of the robot. So this robot has a particularity. As you can see, it has an actuation system very different than what you can see on the Chinese robots. So the actuation system that you can see on the Chinese robot comes from Professor Song Bae Kim from MIT in 2016. And one of the main problems you have with this kind of motors is that they tend to heat up very quickly. Okay, so now the interesting part with this new kind of system is that you have differential motors here, which are less heating up, having stronger charge, mostly because you have a very parallel design from the top, and most of the masses is on this robot. And here you have a heavy charge. I think we can go up to 60 kilograms, and in the frame of the TIRREX project, funded by the France 2030 program, we're going to try to put more heavy loads and see how we can actually extend the test on this robot. So here, the working is using the same kind of technology that you have seen again on the Chinese robot, using reinforcement learning. It worked beautifully in 1 year, where they battled for 2 or 3 years using classical techniques. And actually, one of the students implementing this kind of RL techniques just published a paper with one of the famous founding father of RL, Peter Abil, from Berkeley. So here you can deploy real technology. You can deploy your own system because it's open source, and we, as the research community, will continue. You see testing again this kind of powerful structure, because one of the problems with these heavy robots is when they fall down, very often the impact is cubic to the size of the robot. So most of the times, when a full-size robot fails, it's broken. And here we believe that with this kind of legs architecture, we are far much stronger. And for us, the point is that to develop, again, new technology, partners with a partnership on different kind of companies. So we have an ongoing agreement with Wondercraft. We have in our lab F on H1, so we are trying to compare what we can do with PAL Robotics and other company. But again, what we like with PAL Robotics is they are committed to open source, which gives feedback to the community as a whole. And I think this concludes our presentation.
Okay.
Thank you very much for your attention.
Yeah. Thank you. Thank you, everyone. So yeah, we have really short time to cram in a lot of information. So I really invite you all to come to our booth if you want to talk more in depth about the robots, the applications. Yeah. Thank you, everyone.